All right, guys, for part two of the insulation activity, we're going to look at how a heat lamp affects the curvature of the Earth. So for part one, we were taking into consideration how Earth is tilted, okay? And that's what we were looking at here. We were looking at how the tilt of the Earth affects it. In part two, we're looking at how the curvature of the Earth affects it. And so what we're going to do is we're going to set up this heat lamp, and we're going to record the temperature at the equator, at the 45-degree mark, and then at the 0-degree mark. And we will record that temperature every minute for 15 minutes. And we will record the data, okay? So provided here is a set of data for you to use. So we actually only recorded 5 minutes of data. And so just pause the video and collect this data for the first 5 minutes, and then you're going to make a graph of this data. So the title of this graph is going to be temperature versus time. You'll end up with 3 lines, okay? You'll end up with 3 lines, so you'll have one line for our 90-degree data, okay? You'll have a second line for our temperature data, and then you'll have a third line for your 0-degree data. So just use your own piece of paper, create a sketch graph. All right, so down here at the bottom, I'll kind of give you a basic of how we can set that up. So down here, you're going to have elapsed time. You're going to count first line be 0, then 1, 2, 3, 4, and 5. So you'll space that out on your paper for your graph. And so those 5 times will respond to these 5 at the top, okay? Then you'll graph on the y-axis the temperature of 90. So you'll have one line with this set of data and the temperature at 45. That'll be a second line with this green data. And then finally a third line, temperature or equator of 0, and that'll be a third line. So you'll have to go up for this data to 100, so we can just label this 0 degrees all the way to 100 degrees, and you can just spread that out as you go, counting by probably 5s would work good. All right, and so you just continue that, and you're going to make that graph. You'll end up with 3 lines, one for the 90, one for the 45, and one for the 0, okay? Now, after you make those lines, you will then be prepared to answer the questions that are provided in the lab paper. One other thing briefly before we go is, let's talk about what we expect the temperature to be. So say, for example, the temperature at the 45 is 60 degrees. I don't know what it's going to be. Well, I do know what it's going to be from the data, but if this is 60 degrees, what would you expect this temperature down here at the equator to be? Greater than 60 or less than 60? I would expect, because it's closer to the sun, I would expect it to be some number, the temperature here would be some number greater than 60 degrees. What about the North Pole? Well, the North Pole is at an angle, and we already saw what happens to it at an angle, and it's further away. So what would we expect it to be? We'd expect the temperature at the North Pole to be some number less than 60 degrees, okay? So I just chose 60 as an arbitrary number. But we can see here that this light is directly, and this light has to reach further, and not only does it reach further, but it strikes the North Pole at an angle. So we want to be able to combine those two. So at this point, make a graph of your data using the data provided, and then be sure to answer the questions provided in the lab activity. Thank you.